Hi, geometry class. This is section 3.2. We are going to have several new definitions. So we will be going into Sketchpad to do some sketches and then working a lot in your notebook, which I realize both of those are also on your computer. So if you want to put me on pause and go ahead and open up what you need to have open, your notebooks and Sketchpad, so that you can make the appropriate notes. Okay, so the first thing we're going to talk about in this section is a segment bisector. In chapter 1, we talked a lot about angle bisectors, but we didn't do a whole lot with a segment bisector, but it's going to be the same concept. So your first definition for this section is going to be for a segment bisector. We are talking about a line segment being split into two equal pieces. So for your definition of a segment bisector, it is a line, ray, or segment that passes through the midpoint of another given segment. Okay, so we're going to go into Sketchpad and just do that. So I'm going to construct a line segment. Okay, and I want to bisect the segment. So in order to bisect, I need to find the midpoint. So I'm going to highlight the segment and then construct the midpoint. Now I need to make another line segment array that goes through the midpoint. So I'm going to put another point somewhere, and then I am going to connect the 2 points, and I'm going to make mine a line. Okay, so there we have it. So this line right here, and I am going to give these 2 points a name. So my line AB is a bisector of line segment CD. Now I can go back to my pointer and pull this, oh, my A went away. Go back to my pointer and I'm going to drag A. Doesn't matter the angle that it makes, it is still a segment bisector. Okay, so line AB is a segment bisector of line segment CD. Okay, why don't you go ahead and take a picture of that or snapshot of it and insert that into your notes. Okay, you'll want to include the markings to show what's congruent. So I'm going to mark line segment CB is congruent to line segment BD. Okay, that's what a segment bisector does, is it makes two congruent segments. Okay, so if I take CB and make that a segment and then measure its length, then I can see that it's equal in length to segment BD. So I'm going to highlight BD, construct a segment, and then measure its length. Okay, so they both are 4.5 centimeters long, so we can say line segment CB is congruent to line segment BD. Okay, so that is our segment bisector. The next definition that we want to talk about is if our bisector is perpendicular to the line segment. So a segment has many perpendiculars and many bisectors, but in a plane, each segment only has one of those bisectors that is also perpendicular to the segment. This line is called a perpendicular bisector. So definition in your notebooks for perpendicular bisector. It is a line segment array that forms 90-degree angles with a line segment and also divides it into two congruent parts. Two congruent parts. So if we go back to our sketchpad diagram and look at what we did for just a segment bisector, what would make this a perpendicular bisector? If this line was perpendicular, if line AB was perpendicular to line segment CD. Now we need to construct it so that it's perpendicular, but it does still need to go through the midpoint. So I'm going to take this and I'm going to hide this line. Okay, then I'm just going to highlight point B in line segment CD and say construct a perpendicular line. Now I'm going to go and put a point A back on there. It will probably call it something else. Yes, E. That's okay. So in this case, line EB is perpendicular to line segment CB. It is also a segment bisector, so we call it a perpendicular bisector. So in your notes we want to write that line EB is a perpendicular bisector of line segment CD. It forms 90-degree angles and passes through the midpoint of segment CD. So there's your perpendicular bisector. We can measure angles CBE. And show that it's 90 degrees. Wow. So you can see the 90-degree marks. Probably could have done it with this as well, showing the segments. Let's see. So there we go. So now you can put that picture in your notes with perpendicular bisector. Please put the video on pause anytime you need to. Spend more time. Okay, our first conjecture of section 3.2 is the perpendicular bisector conjecture. If a point is on the perpendicular bisector of a segment, then it is blank from the endpoints. So we're going to go back to our picture. So here's my point E. It is on the perpendicular bisector. How far away is it from point C, and how far away is it from point D? So I'm going to highlight point C, and then I'm going to say measure distance. So line segment EC is 8.33. I'm going to move this out of the way. And then I'm going to measure the length E to D. And I'm going to say, I'm not going to construct the segment. I'm just going to measure the length. E to D is also 8.33. If I move point E around, those distances stay the same, no matter where E is on the perpendicular bisector. If you will remember, this is how we constructed our isosceles triangle. So the length from E to the two endpoints is the same, and it is, in this case right now, 8.78. So to complete our conjecture, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints. So you will want to fill in the word equidistant. And then we want to talk about the converse of this statement. What about the converse of the statement? So the converse would be if a point is on a line segment that is equidistant from the endpoints of another segment, is it perpendicular and a bisector of the original statement? So what do you think about the converse? Is that going to be a true statement? Indeed it is. So the converse of the perpendicular bisector conjecture is your next conjecture, conjecture 6. If a point is equidistant from the endpoint of a segment, then it is on the perpendicular bisector of the segment. So you can fill in perpendicular bisector into the blank, and that is conjecture 6. Okay, we have a couple more things to talk about in this section, and one of them is the median of a triangle. We did talk about this a little bit in chapter 1, but we want to make it an official definition in your notebook. So the definition of a median is the line segment connecting the vertex of a triangle to the midpoint of its opposite side. Put me on pause and make sure you get that definition into your notebook. There are 3 midpoints and 3 vertices in every triangle. So every triangle has 3 medians. And you guessed it, we're going to go into Sketchpad and make medians. So I'm going to start with a new sketch for this. I'm going to pick 3 points and just make a triangle. We're going to be doing a lot of this. So make sure you're comfortable with the definition of a median. Okay, so I've constructed a triangle. I've already got one segment highlighted, so I am going to go ahead and construct its midpoint, and then I'm going to construct the other 2 midpoints. And you can do that in your original construction there all at once if you want to. So now I have 3 midpoints. So now if I highlight a vertex with the midpoint across from it and construct a segment, that is a median. Okay, so let's name our median. So I'm going to make these points. So line segment AB is a median. I'm just going to leave it like that. Now I need to show that B is the midpoint. So I'm going to go ahead and give all these other points a name, and we'll talk about them. I'm going to use my pen, and I'm going to construct these segments first. So I'm going to highlight C to B and say construct segment. Oh, it won't let me. Okay, let me try again. C to B, construct segment, and then B to D, construct segment. Now, when I go into with my pen and click on that segment, it will give me tick marks. And I can do that all the way around my triangle. I am going to construct the other medians. So if I highlight C and highlight E and say construct segment, Line segment CE is a median. I want to make the appropriate mark, so I'm going to construct AE as a segment, ED as a segment, and then I can use my pen and mark them. I want to give these double tick marks because I don't know if they're congruent to the other ones. And then I'm going to do this one more time. So I'm going to connect point D from the vertex D to the midpoint F. And when I construct that segment, I am constructing another median. You should notice something very coincidental about those three medians, which we're going to talk about later in this chapter. So I'll go ahead and construct these smaller segments, and we can finish up our drawing. So line segment DF is a median, and line segment AB is a median. Okay, so make sure you take a picture, snapshot it, and put it in your notebook to go with the definition of a median. Remember, it goes from the vertex to the side opposite at its midpoint. Okay, lastly, we're going to talk about a mid-segment. The definition of a mid-segment is the segment that connects the midpoints of two sides of a triangle. A triangle has three sides, each with its own midpoint. So there are three mid-segments in every triangle. Okay, notice the picture that's already there. But we are going to go into Sketchpad and make our own. So I am going to hide the three medians so that we don't have to start from scratch. So looking at this picture, I see a triangle ACD with midpoints F, B, and E. So if I'm going to construct mid-segments, I will connect F to B, and that is a mid-segment. If I connect B to E, it is a mid-segment. And if I connect F to E, it is a mid-segment. So notice what the mid-segments do to your triangle. So let's write a caption to go along with this definition. Line segments FB, FE, and BE are mid-segments of triangle ACD. You'll want to take a picture of this and put it in your notebook to go with your definition of mid-segments. Okay, that concludes the notes from section 3.2. I know that this was a long video, lots of new information. I want you to go back and look at it and make sure you're comfortable with all those definitions and conjectures. And so there's no problems to do at the end of this video. I will check your notes in class tomorrow and make sure you have the snapshots with them for your homework credit. And I'll see you in class.